Imagine a world submerged, ruled not by land-dwelling giants, but by creatures of the deep. A realm where ancient oceans held secrets far more astounding than any land beast. Among the earliest and most enigmatic of these marine titans was a creature whose very appearance defied conventional understanding. Plesiosaurus. Its name, meaning near lizard, hints at its perplexing nature, a blend of features that confused and captivated early scientists. For centuries, legends of sea serpents and leviathans filled mariners' tales. But in the early 19th century, a series of extraordinary discoveries along the rugged English coast began to offer real, fossilized evidence of immense, long-necked reptiles that truly roamed the ancient seas. These weren't mythical beasts. They were the genuine, prehistoric inhabitants of Earth's vast oceans. What made this particular marine reptile so revolutionary? Why did its unique combination of a long neck, a compact body, and four powerful flippers spark such intense debate and challenge existing biological classifications? How did a creature so unlike anything alive today help to redefine our understanding of prehistoric life and the very concept of extinction? The story of Plesiosaurus is more than just the tale of an ancient marine reptile. It's the chronicle of how science grappled with the sheer alienness of prehistoric life. Join us as we plunge into the captivating history of Plesiosaurus, from its initial bewildering fossil fragments to its modern scientific interpretations. We'll explore the groundbreaking discoveries, the scientific rivalries, and the enduring mysteries surrounding this iconic marine reptile. Prepare to meet the serpent of the seas that navigated the ancient depths, leaving a legacy that still intrigues us today. Our journey back in time begins in the early 19th century, a period of burgeoning scientific curiosity in Europe. However, the world of natural history was still largely governed by prevailing religious and philosophical views. The concept of extinction was a particularly contentious idea. Many naturalists and theologians believed that God would not allow any of his creations to simply vanish from the earth. Any strange fossils found were often attributed to exotic living animals from distant lands, deformed specimens, or even creatures that had perished in a global flood, such as Noah's Ark. The science of geology was slowly beginning to challenge these static views. Pioneer geologists like William Smith, with his groundbreaking work on stratigraphy and the identification of fossil layers, were demonstrating that Earth's history was far more ancient and dynamic than previously imagined. Fossils, once seen as mere curiosities or sports of nature, were increasingly recognized as the remains of past life forms. However, identifying and classifying these ancient remains posed immense challenges, especially when they belonged to creatures unlike anything known to exist. It was against this backdrop that one of the most remarkable figures in paleontological history emerged: Mary Anning. Born in 1799 in Lyme Regis, Dorset, a small town on England's Jurassic coast famed for its fossil-rich cliffs, Anning was a self-taught fossil collector who began her work at a very young age, often alongside her father and brother. Despite her humble origins and lack of formal scientific education, a significant barrier for women in 19th century science, Mary Anning possessed an unparalleled eye for fossils and an uncanny ability to extract them from dangerous, eroding cliffs. Anning's initial major discoveries were pivotal. In 1811, her brother Joseph found a skull, and a year later, Mary found the rest of the skeleton of what would become known as the Ichthyosaurus, the fish lizard. This was a truly astounding find, a large marine reptile perfectly adapted for life in the ocean, with a fish-like body, powerful tail, and paddle-like limbs. Its existence defied previous classifications and confirmed the presence of ancient, aquatic predators unlike anything alive. The Ichthyosaurus was widely discussed in scientific circles, firmly establishing the concept of marine reptiles. However, even with the acceptance of Ichthyosaurus, the scientific community was still grappling with how to categorize these bizarre, extinct creatures. The understanding of evolution was decades away, and the prevailing view of biological diversity relied heavily on Carl Linnaeus's system of classification, which was based on existing life forms. How could one fit a creature that was neither fish nor lizard in the traditional sense, yet shared characteristics of both? The stage was set for an even more perplexing discovery, one that would further stretch the boundaries of what scientists believed was possible in the natural world. This next discovery, made by the tireless Mary Anning, will be the very first Plesiosaurus. Its bizarre anatomy would challenge even the most open-minded naturalists and force a radical rethinking of prehistoric life. In 1823, Mary Anning made another truly astounding discovery along the treacherous cliffs near Lyme Regis. She unearthed a partial skeleton of a creature even more perplexing than the Ichthyosaurus. This fossil, initially fragmented, presented a baffling combination of features: a remarkably long neck, a small head, a compact, turtle-like body, and 4 large, paddle-like limbs. It was unlike any animal, living or extinct, known to science. The renowned British paleontologist and anatomist William Conybeare was given the task of formally describing Anning's find. In 1824, Conybeare published his detailed description, coining the name Plesiosaurus dolichodirus, meaning near lizard with a long neck. The near lizard part of the name reflected its perplexing anatomy. It was a reptile, but one so radically different from known lizards that it almost defied classification. Its most striking feature was its elongated neck, which contained over 30 vertebrae, a truly unprecedented number for a reptile. Early interpretations of Plesiosaurus's locomotion and lifestyle were highly speculative. Some scientists imagined it as a slow, clumsy swimmer, perhaps even wading in shallow water like a long-necked swan. Its long neck was initially thought to be highly flexible, perhaps even capable of coiling like a snake to strike prey. The 4 paddle-like limbs, so different from the fins of fish or flippers of modern marine mammals, presented a unique puzzle regarding propulsion. The discovery of Plesiosaurus ignited considerable scientific debate, even skepticism. The eminent French anatomist Georges Cuvier, who had initially been skeptical of Ichthyosaurus, but later accepted its validity, famously expressed disbelief at the initial Plesiosaurus reconstruction. He reportedly exclaimed, "My God, it is more like a snake threaded through a turtle." This quote perfectly encapsulates the sheer strangeness of the creature to early 19th century scientists. Cuvier suspected a forgery or a composite of different animals, so outlandish was its anatomy. However, subsequent finds, including a more complete skeleton also found by Mary Anning in 1823, though sold to the Duke of Buckingham for his private collection, eventually convinced Cuvier of its authenticity. As more complete Plesiosaurus fossils were unearthed throughout the 19th and 20th centuries, our understanding evolved dramatically. Scientists now generally agree that Plesiosaurus, and indeed, most plesiosaurs, used all 4 flippers for propulsion in a unique underwater flight motion similar to how sea lions or penguins move through water. Each flipper acted as a hydrofoil, creating lift and thrust. This method of propulsion suggests an agile swimmer, capable of both bursts of speed and sustained cruising. The long neck, while flexible, was likely not as serpent-like as initially imagined. Its primary function was probably to allow the animal to strike at fast-moving prey from a relatively stationary body, or to ambush schooling fish without having to move its entire large body. Plesiosaurus was a relatively small plesiosaur, reaching lengths of about 3 to 5 meters, 10 to 16 feet. Its diet consisted primarily of fish and cephalopods, like squid and belemnites, as evidenced by fossilized stomach contents and the sharp, interlocking teeth suited for grasping slippery prey. Its habitat was the shallow, epicontinental seas of the early Jurassic period, roughly 200 to 175 million years ago, making it one of the earliest known true plesiosaurs. The discovery of Plesiosaurus, alongside Ichthyosaurus, cemented the concept of marine reptiles a distinct group of reptiles that had fully adapted to life in the oceans, a stark contrast to land-dwelling dinosaurs. This differentiation was crucial for understanding the diversity of prehistoric life and recognizing that different branches of reptiles had evolved to fill different ecological niches. It also paved the way for the discovery of other marine reptile groups, such as mosasaurs and nothosaurs. The Plesiosaurus problem, how such a creature could exist and thrive, forced scientists to reconsider their preconceived notions about biological forms and functions. It demonstrated that nature's designs could be far more varied and specialized than previously thought. The fact that the first complete skeleton, also found by Mary Anning in 1823, the one bought by the Duke of Buckingham, was so perfectly preserved, showcasing its bizarre features, helped to solidify its acceptance. This particular specimen eventually made its way into the British Museum, becoming a celebrated exhibit. The legacy of Plesiosaurus extends beyond scientific classification. Its unique shape, particularly the long neck emerging from a stout body, has profoundly influenced popular culture. It is the creature most often associated with sea monsters and, most famously, with the Loch Ness Monster. While Nessie is firmly in the realm of cryptozoology and folklore, the enduring image of a long-necked, four-flippered creature in mysterious waters is a direct descendant of the early, awe-inspiring reconstructions of Plesiosaurus. This connection highlights how deeply this ancient reptile has permeated human imagination, forever linking it to the mysteries of the deep. The journey of understanding Plesiosaurus is a fascinating blend of scientific rigor and enduring myth. Today, our understanding of Plesiosaurus has advanced far beyond the initial awe and confusion of the 19th century. While it remains an iconic early plesiosaur, modern paleontology has placed it within a much broader and more diverse group of marine reptiles. The study of Plesiosaurus itself and the wider plesiosaur group continues to be a vibrant field, utilizing cutting-edge technology and interdisciplinary approaches. One key area of current research involves revisiting type specimens like the original Plesiosaurus dolichoderus fossils. Scientists are using advanced imaging techniques, such as CT scans and 3D modeling, to create incredibly detailed digital reconstructions of the bones. These non-invasive methods allow researchers to examine internal structures, muscle attachment points, and even growth patterns with unprecedented precision, revealing new insights into its locomotion, feeding mechanics, and overall physiology. For instance, detailed analysis of its neck vertebrae now suggests that while flexible, the neck was likely not capable of the extreme, coiling movements often depicted in older artwork. Phylogenetic analysis has also become incredibly sophisticated. Plesiosaurus is now understood as a genus within the larger order Plesiosauria, which includes a vast array of long-necked plesiosauromorphs and short-necked, large-headed pliosauromorphs, marine reptiles that thrived throughout the Jurassic and Cretaceous periods. Modern classification helps us understand the evolutionary relationships between different plesiosaur groups, revealing their diversification strategies and how they adapted to various marine environments. We can now trace the evolutionary paths that led to giants like Elasmosaurus with its incredibly long neck, or the fearsome Kronosaurus with its massive skull and powerful bite. Dietary and ecological studies are also ongoing. By analyzing tooth morphology, jaw mechanics, and even rare fossilized gut contents, paleontologists gain clearer insights into Plesiosaurus's diet. While fish and cephalopods remain the primary suspects, some studies explore the possibility of opportunistic feeding on small marine invertebrates. Understanding its diet also helps to reconstruct the intricate food webs of the early Jurassic oceans, revealing its specific niche within a complex ecosystem. The discovery of preserved fish scales or squid beaks within a plesiosaur skeleton offers invaluable direct evidence of its last meal. The debate surrounding plesiosaur locomotion is still a lively one, though the underwater flight model using all four flippers as hydrofoils is widely accepted. However, researchers continue to refine the nuances of this motion, using fluid dynamics and robotic models to understand the precise forces generated by the flippers and the efficiency of their swimming. Some theories explore differences in swimming styles between long-necked and short-necked plesiosaurs. The public image of Plesiosaurus has largely shifted from the static, snake-like monster to a dynamic, graceful swimmer. Modern museum exhibits and documentaries feature scientifically informed reconstructions, often depicting the animal in active poses, showcasing its incredible adaptations for marine life. Despite this, the connection to the Loch Ness Monster persists in popular culture, a testament to the enduring mystery and appeal of this unique creature. Scientists frequently engage with the public to clarify the differences between real paleontology and cryptozoology, using the Plesiosaurus as a prime example of a scientifically documented ancient marine reptile. The ongoing challenges in Plesiosaurus research include the scarcity of truly complete specimens, especially those from outside the well-known sites like Lyme Regis. Furthermore, inferring soft tissue anatomy, like musculature or internal organs, from skeletal remains is always an interpretive challenge. However, the dedicated work of paleontologists worldwide continues to chip away at these mysteries, making Plesiosaurus a compelling subject for both academic study and public fascination. The future of Plesiosaurus research is incredibly promising, driven by burgeoning technological capabilities and an ever-expanding global network of fossil hunters. We can anticipate even more profound insights into this serpent of the seas in the coming decades. One significant area of future focus will be the application of advanced computational fluid dynamics, CFD. By creating highly detailed 3D models of Plesiosaurus and simulating its movement through water, scientists can gain an unprecedented understanding of its hydrodynamic efficiency, power output, and maneuverability. This could lead to a definitive understanding of subtle differences in swimming styles among various plesiosaur species and how factors like neck length influence their speed and hunting strategies. Imagine simulating a plesiosaur's escape from a larger predator, analyzing every twist and turn. The discovery of new, incredibly well-preserved fossil sites holds immense potential. While the Jurassic coast remains a treasure trove, exploration of previously unexamined marine sedimentary basins around the world could unearth new plesiosaurus specimens, or even entirely new genera of early plesiosaurs. Discoveries that include soft tissue impressions, stomach contents, or even trace fossils, like scratch marks on the seabed from a resting plesiosaurus, would be revolutionary. For example, finding evidence of skin texture or dermal ossifications could provide clues about its thermoregulation or defense mechanisms. Genomic and proteomic studies, while extremely challenging for ancient marine reptiles, are an aspirational goal. As preservation techniques and analytical methods improve, the possibility of extracting and analyzing ancient proteins or even fragmented DNA from exceptionally preserved fossils could offer unprecedented insights into Plesiosaurus's physiology, evolutionary relationships, and even its coloration or immune system. While the prospect of cloning remains science fiction, understanding its molecular biology would be a game changer. Furthermore, the integration of virtual reality, VR, and augmented reality, AR, will transform how we study and present Plesiosaurus. Paleontologists could use VR to walk around and examine 3D models of complete skeletons from anywhere in the world, collaborating on reconstructions in real time. Public exhibitions could offer immersive experiences, allowing visitors to dive into a virtual early Jurassic ocean and observe Plesiosaurus in its natural habitat, interacting with other prehistoric marine life. This will make the science more accessible and engaging than ever before. Finally, continued advancements in geophysical surveying techniques could lead to the identification of promising fossil beds hidden beneath the seabed or within inaccessible cliffs. Technologies like advanced sonar, seismic imaging, and even remote sensing drones could pinpoint locations with high potential for preserving marine reptile fossils, leading to targeted excavations and more efficient discoveries. The future of Plesiosaurus research is a thrilling prospect, promising to unlock even more of its long-held secrets. Each new piece of evidence and every technological leap brings us closer to painting a complete and vivid picture of this enduring marvel of the ancient seas. From its bewildering initial discovery by Mary Anning to its current status as a meticulously studied subject of modern paleontology, the story of Plesiosaurus is a captivating journey through scientific discovery and evolving understanding. This near lizard with a long neck was a creature so unique, so alien, that it challenged the very foundations of 19th century biology. We've explored its perplexing anatomy, that long neck, compact body, and 4 powerful flippers, and seen how it forced scientists like Conybeare and even the skeptical Cuvier to accept the incredible diversity of life that once thrived in Earth's oceans. Plesiosaurus was a pioneer, helping to establish the concept of distinct marine reptiles and paving the way for countless other prehistoric discoveries. Today, Plesiosaurus remains a vital link in the evolutionary tapestry of marine life, its existence a testament to nature's boundless creativity. It continues to inspire wonder, not just in scientific circles, but also in popular culture, where its shape endures as the quintessential sea monster archetype. So, the next time you gaze at the ocean or ponder the mysteries of deep time, remember Plesiosaurus. It's a powerful reminder that our planet's history is filled with astonishing creatures, and that the pursuit of knowledge is an endless, fascinating voyage. The ancient seas truly held wonders beyond imagination.